be an underestimate or overestimate of that interval. So what might you do to answer the question? Sorry? Draw it out. So just make a note to yourselves in case you're saying, just say fx increasing concave up, right Riemann sum. That's enough for you to, if you're in the habit of looking at your notes, that should jog in memory. So as Mr. Sanwan correctly says, draw it out. So it says increasing and concave up. So something like that. What should I do next? Draw lines. In case you've forgotten how to draw right Riemann sum, just draw parallel lines. You just need to draw one rectangle, you're good to go. So see, this comes back to you. Here's how you draw right Riemann. Go to any vertex. Sorry, Mr. Cooper, I made it here. It's like, man, how do I? It's really annoying. Here's how you do right Riemann sum, like that. You should get the hang of this. And the question says, will that area be an underestimate or overestimate of the actual area? Remember, this is the actual area under the curve. Over, just say overestimate. That's it. So it'll come with a multiple choice, you'll have to choose. Okay, question number 2. Stay with me. It says, estimate the average value of f over the interval 1 to 4 using a midpoint Riemann sum. Who remembers vaguely what you should do if you're asked to calculate Riemann sums using a graph?
Make your own points.
Make your own table. Make your own table. Okay. So we need to focus only on 1 to 4. So I'll just go, this is x, y. So 1 is roughly about 7. Okay. 1.5 is roughly about 9. 2 is roughly about 10. 2.5 is roughly about 9 again. 3 is roughly about 8. 3.5 is roughly about 6. And finally 4 is roughly about 3. The question says average value of f. So what should I write on a sheet of paper? 1 over 4 minus 1. It's not right like AB, average value, equals 1 over 4 minus 1, integral from 1 to 4, f dx. What should I not forget to do that some of you, in spite of repeated importunities, I think I should just switch with a simpler word, objuration. I could use conjuration too, or supplication. All mean the same. What should I not forget to do? Bring down that 1/3. Okay. Now, by the way, we're using a midpoint Riemann sum, using 3 rectangles. So is that my first rectangle, second rectangle, third rectangle? Okay. So what am I writing? Times 9. Yeah, that's 1 base times height, plus 1 times, and then plus 1 times 6, exactly. Or on the final, I may want you to simplify this. If you have given numbers, it'll be simple numbers. Okay, that's 9 plus 9, 18 plus 6, 24 over 3, which is 8. Exactly. But this is key. This is key. This is key. So I'm kind of emphasizing that concept. All right. Oh yeah. Okay, that's fine. All right. Read the question. There is a question like this on your final. It was there yesterday on your homework, but a good teacher reviews important stuff in class. It says find the derivative of that. Therefore, FTC2. We're finding the derivative of an interval. Okay, tell me what to write. Equals
G or X.
X, exactly. For those of you who have forgotten, we plug in the upper limit times the derivative minus lower the limit times the derivative. So radical x squared becomes x minus 3 radical x plus 1 times parentheses times 1 over 2 radical x minus a careful parentheses
E to the X4.
You mean 4x, you fool. E to x squared, 4x. Continue. Plus 1 times 2 e to 2x. Exactly. Just leave it alone. Chain rule, applying the chain rule. E to 2x dash is just 2e2x. So you plug in the upper limit measures and then into all the x's.
Wouldn't it be 4x squared to the
What? No, e2x squared. Multiply. Okay? Just leave it alone. It's fine. If it is a multiple choice question, just look at one of the choices. Number 4. We kind of did these problems yesterday, but because this is guys. The last 2 chapters are being over-represented on your final. Repeat. The last 2 chapters, this chapter and the next chapter, are being over-represented, letting you know that. The fewest questions will come in limits and continuity. Even on the AP, it's the least important. Applications of derivatives, this and the next chapter the most. It says over what interval is capital F of x increasing and concave up? If any function is increasing, what must be true? F dash. So therefore we should deal with FTC2. Alright. So we're doing number 4. So capital F dash of x equals careful, tell me what to write. 3 x to the power of 4 minus times 2x, careful, tricky question. Minus 0, kids who are ahead, yes? When you plug it in times derivative, that's just 0, yeah? So that's f of x, right? That's just like f of x. Should we simplify this? And we need greater than 0, less than 0, right? Increasing, decreasing. So, is that what? 6x to the power of 5 minus 2x cubed. What could I do next step? Careful. Factor order 2x cubed. Careful. What comes inside? 3x squared, which is really radical 3x minus 1, radical 3x plus 1. Everybody okay there? Eventually, are we merging number lines? Yes? Then capital F double dash of x, which is f dash of x, will be 30x minus 6x squared. What could I take out? What comes in 6x squared? What comes inside? Which is really, again, is that clear? So this is capital F dash, this is capital F double dash. Yeah? So your roots are 0, 1 over radical 3, negative 1 over radical 3. This is 0. Common sense. 1 over radical 5 is bigger than 1 over radical 3 or smaller? Common sense. Just think of it 1/3 and 1/5. Which is bigger, which is smaller? Huh? Is 1 over, where am I putting 1 over radical 5? Yeah, smaller, okay, because you're dividing by bigger number. Is this plus minus plus? Oh, not for this guy, right? For this guy, it's odd, odd, odd. Okay. Plus, minus, 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 minus. Plus, 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 plus. Minus, minus.
How many pluses?
And then this guy is plus. Careful, what's happening at 0? Staying the same, yeah? The question says increasing and concave up. Final answer?
Why did you just say it should be?
Sorry? At 0 it stays the same. And then the other guy flips. Right? Yeah. So what's going on? Increasing and concave up. Negative infinity to, no, not negative infinity. Negative 1 over radical 3 to, thank you, negative 1 over radical 5, comma.
Wait, but if it's stated.
I'm going to ignore you just for a second. Go on, continue.
1 over radical.
Ah. How about 0 to? Don't figure that. Oh no, increasing. You're right. Sorry,
No,
sorry.
it's
1
1
over
over
radical 3 to
radical
infinity. Okay, sorry. I was not paying attention to increasing. Yes, Mr. Nava.
But if it starts off positive and at 0 it's squared, so it
No,
stays.
no. At 1 over radical 5 you're flipping, and then at 0 it stays the same. Okay. I was giving you an opportunity to figure it out yourself, but you didn't. So I had to step in. Okay, number 5. We won't do every problem, we'll set them up though. So you get a feel for this. I want you to just write down that. Okay, I'll focus on what you need to write down. Write that down, and then this guy, this guy, this guy. Actually, you can make it negative 4 to 2 for all of them. Okay? Just make it negative 4 to 2 for all of them. So each is different. If you're actually brilliant, you would say average rate of change of capital F of x, F dash of x, F double dash of x. Okay? Reduce the amount of stuff you write. And Mr. Boardman was saying, I don't write anything. What's the idiot Boardman? He's supposed to be here. These are the chapters he kind of screwed around with. Yeah, make that negative 4. Okay, let's be consistent. Alright. Alright, we're doing A. How do we do average rate of change of capital F of x? What am I writing? Big F of negative 4 minus big F of 2 over negative 4 minus 2. Yes? Should I basically find big F of negative 4 big F of 2? So sidebar, big F of negative 4 equals, what am I writing? Work-wise.
F of negative
1 to negative 4 F dt, yes? Is that basically area under the curve from 1 to negative 4? Let's have a look. What's going on? Erase this. From 1 to negative 4. 1, 2, 3, 4. Okay. What's that area? Careful. Careful. 1 or negative 1? Positive 1. We're going 1 to negative 4. Okay. So equals positive 1. And then, is that a circle with radius 2? So pi 2 squared. Pi 4 divided by 4, which is? So plus pi, yes. It's below the axis. And then finally, what's this area? Oh, bloody hell. Oh my god. That is going to be a biatch. Let's just go negative 5, guys. Just change it to negative 5. I'm not in the mood to find the equation line. Yeah, guys, can you see? That's not at the halfway mark. Can you see that? That's probably the 2/3 mark. All right. I don't have. Yeah, I believe it was like 0.66 or something. All right. Let's just make it a negative 5. Okay. So that's 3. 1, 2, 3, 4, 12. Is that 6? Okay. Plus 6, which is 7 plus pi. Likewise, what do we find next? F of 2, which is 1 to 2 F dt. That's easy, just 1 to 2. And that area is just 1. Okay? And we can plug it in. Is that clear? Again, we're just going to set up the problem so you get a feel for what's going on, how to do it. Slow and steady, guys. Okay. The next question says the average rate of change of capital F dash. So what do we write for that? Big F dash of negative 5 minus big F dash of 2 over negative 5 minus 2. So what should we find first? Big F dash of x. Is that clear? So is that FTC2? And that's simply, is that f of x? So does the problem really become f of negative 5 minus f of 2 over negative 5 minus 2. Guys, it is smart to show work, because Ms. Manrique would. Blush. Okay. Alright, now can we just read off the graph? What's f of negative 5? Negative 4 minus f of 2, 2 over negative 7 or negative 5 minus 2. Okay. Straightforward. Show the work, you're better off. There are lots of things going on. Don't just skip. No. That's FTC2. Find capital dash of x. Showing you how to get it right every single time. And part C says average rate of change of capital F double dash. But what's F double dash really? This is F dash of x. So I need F double dash of negative 5 minus F double dash of 2 minus negative 5 minus 2. is basically f dash at -5. Oh, we'll have to change that to -4 actually to this problem. Because here's why. Here's why. Can you see the slope does not exist there? It's an endpoint, correct? So we choose that. But of course, the smartest kids are thinking, the slope there is pretty much the same, right? So we'll make it -4. I want to be technically accurate. I don't want Fino screaming at me. I don't care if anybody else except his disapproval. It's so judgmental. Okay, -4 minus 3. Sorry about that. Okay, what's the slope at -4? Careful. Is that 4 over 3? You're rising 4 across 3. So that's 4 over 3 minus. What's the slope at 2? Is it just 2? You're rising 2 across 1 over -6. Is that clear? See if that makes sense again. So each problem is slightly different. But please show the work. Interpret the problem exactly the way it's written. Oh, it should be above. Ms. Yusing, can you say change that to above? Okay, good. The derivative of a function is given above. Okay. By the way, you have a question like this. You have a question like this. So that's f dash. They're giving you f dash. Write down the given information. They say f of 4 equals 5. Write that down. And the question says find f of -2. And they're giving us f dash. This is the f dash here. So how do I find f of -2? Let's change corollary. Number 6. So f of -2 equals plus integral from 4 to -2 f dash. F of 4 is given to be 5 plus integral from 4 to -2. Oh yeah, from 4 to -2. Let's have a look. This is 4. I'm seeing on the board. 2, 3, 4. From 4 to -2. Is that clear? We're going that way. Keep that in mind. Can we find the area? Oh, 4. Can we find the area of that rectangle? Which is what, 4? Really? -4. We're going right to left. Careful. So the area of that rectangle is -4. And then can we go area of the triangle, which is 4, was it? Or -4 actually, right? -4. Okay. Area of this triangle, +1. And then the area of that semicircle, +pi. Is that clear? That's your final answer. Slow and steady, slow and steady. Show the work. And keep track of signs. Right to left, signs flip. Keep track of that. Okay. That was good, easy. All right, you have one question like this, especially on distance, all right? We'll set up A, but we'll kind of do more about B. So it says the velocity of the object is given. Write this down. We learned this yesterday, you're getting a second peek at it. So V of t equals 40 minus t squared. And the question says, find the displacement of the object from 0 to 3. In other words, just what's the change in position? For those of you who get confused, the change in position means account for the negative, guys. It's okay if you're negative. So you're going farther away and then getting closer. So what do we just do for 7a? So displacement right to the left hand side. Displacement equals integral 0 to 3. Just v of t. 40 minus t squared. Think of your answer. Yes absolute value, no absolute value. No absolute value. Displacement means account for when it's negative, the object is going closer to the origin, so we're okay. We are getting closer. Is that clear? And that's stupidly easy to do, right? Now we'll do B, which is the total distance traveled. So when you're getting closer, traveling to the left perhaps, then you need to account for the fact that you're actually traveling a distance. So distance, right, the left hand side is, what's the formula for distance? 0 to 3, absolute value of 40 minus t squared. We learned this yesterday, or reviewed this yesterday, so what should we find first? The x-intercepts. Find the x-intercepts yourselves, go on. Look down, find the x-intercepts. Four? Bloody hell, what's up, stupid? Is 4 completely useless? I'm saying 0 to 3. Okay, we'll change the problem. I don't know if you wrote this down. You probably didn't. We'll make it 0 to 5. All right, so it's useful. We'll make it 0 to 5. So how do I set it up? We'll make it 0 to 5. All right. So how do I set it up?
0, 3.
Absolute value. 0 to 4. 14 minus t squared dt. Absolute value close. Plus 4 to 5. 14 minus t squared dt. Absolute value. So there is one question like this. It's bloody tedious, but slow and steady. Integrate this, integrate this. Yeah, we'll actually do this for practice. Okay. This is going to be done. Look down. Integral of 4t. So it's, what am I writing? 2t squared, correct? Minus p cube over 3, 0 to 4, plus, we already have the integral, right? So that's 2t squared minus t cube over 3, 4 to 5. Okay, keep looking down. I'll walk you through it. And then 4 squared times 2 minus 4 cubed, 64 over 3. Minus 0. Yes, that vanishes. Plus, make sure you're putting absolute values. Don't skip steps. 2 times 5. Oh, sorry. 5 squared times 2, 50. Minus 5 cubed, 125 over 3. Careful. What should I remember to do next? Minus parentheses. 4 squared, 16 times 2, 32. We already have that. Minus 64 over 3. Yes? Okay. Now, slow and steady. I'm going to open this up. Can we use fraction trick here? Can we use fraction trick here? What's 96 minus 64? Is that 32?
Sure.
So 32 thirds. Do I really need the absolute value?
No.
It's just 32 thirds. Okay. Plus, so the absolute value actually applies here. Okay. I'm going to open up this thing. 50 minus 125 thirds minus 32 plus 64 thirds. Yes? Yes? And then 50 minus 32? 18? Negative 125 thirds plus 64 thirds. Negative 61 thirds? Yes? Ah, I'm right. This is the bigger guy, so we're going to get a negative number. 18 times 3, 54, I got it. 54 minus 6, so sorry, minus 61? Negative 7. Ah, so does that really become plus 7 thirds? Everybody okay there? The absolute value. Final answer, 39 thirds, which is? Okay, slow and steady, slow and steady. It's just like this, a little bit of a biatch, but slow and steady. Only the very top is like Ms. Nav's got, the top kids got that right. Only because you have to be careful with your arithmetic. Not the calculus, everybody gets the calculus right. The arithmetic, careful, parentheses, open it up, blah, blah, blah. All right. We're doing number 8. So distance problem, make sure you do absolute value of velocity. Break down, observe the interest. Don't copy the table, just write down the given information. It says, the table below gives the rate at which waste is processed at a treatment facility. So they're giving us the rate function, keep that in mind. All right. This is the rate function. So it is smart to actually define the original function. So what should we call the original function? Say amount. You can't say W, because W is given to be the rate. That's a tricky, okay, that is a release question. Okay, that is a release multiple choice question. They give us W, so you're thinking, okay, should I call the amount function W? No, but that's the rate. So A of t be the amount of waste. Therefore, A dash of t equals W of t. Okay, now let's read what's going on. It says at t equals 3, there are 15 tons of waste. Is that A of 15? Sorry, A of 3. Using n equals 4 rectangles and a trapezoidal Riemann sum, estimate the amount of waste at 55. So what are they asking for? What are they asking for? A of 55 equals
A of
3 plus 3 to 55, A dash, which is W of t, dt. Please, I'm begging you, set it up correctly. Don't just do the Riemann sum. It's very tempting to do so. Slow and steady. So it's 15 plus, okay, we're doing trapezoidal Riemann sum. I'm going to walk you through it slowly. Don't forget, guys, I'm speaking to those are the heights of the trapezoids. This is the distance between the parallel sides. Is that clear? These are the parallel sides, that's the distance between parallel sides. Tell me what to write. Sorry? What? Oh, now, okay, you're fine, but show the work. Negative 6 plus 3 divided by 2 times 7. Again, average of the parallel sides times the distance between parallel sides. Plus 3 plus 7 over 2 times 7 plus take away 15 over 2 times 19 plus negative 15 plus 29 over 2 times 19 again. Okay. Simplify. I might actually ask you to find the value. Just do the math. Do the arithmetic. Another question like that, but the reason was the function is different. Okay, the concept is exactly the same. So it says, consider that over what one interval is f of x increasing concave down. Guys, let me make it easier. Let's just do concave down. Okay? Let's just do concave down. Oh, or actually both. It's not a big deal. I just did the math in my head. It's not too bad. So, what concept are we applying first? FTC2. So we have capital F dash, which is basically f of x. It is simply x minus 3 over x squared plus 1 times minus 0. Yes? Should I do another line for this guy? Yes? What's your only root? 3. 3. And what about ID? Plus and minus. Is that clear? This guy does not have roots. Let's do capital F double dash, which is f dash of x, which is bottom whole square, top left, parentheses times minus parentheses times. Okay, look down, simplify, look down and simplify. Look down. Okay, did I do this right? This is my numerator. I'm just staring at it. Is my numerator correct? Yes? No? Plus 1? Oh, yeah, plus 1. Okay, plus 1. Over, thank you, x squared plus 1 whole square. Okay, just distribute, simplify. What should I do on top? Take out a negative. I'm showing you algebra. The reason I created this problem is to show you algebra. X squared minus 6 minus 1. Guys, it does not factor. Therefore, quadratic. You don't have an option, all right? 6 plus or minus, look down. 36 plus 4 over 2, which is 6 plus or minus radical 40 over 2. Radical 40 actually breaks down. I don't know if you have your basic skills. That's 2 radical 5. No, 16 times 5. 4 radical 5, right? So it's plus or minus 4 radical 5. Why is that important to? Look at me. That actually can break down. 6 over 2 is? And 4 over 2 is? So that is really a root. Okay, I'm going to plot it. So capital F double dash. Common sense. Guys, is it obvious that 3 plus 2 radical 5 is bigger than 3? It's bigger than 3. So that's here. 3 plus 2 radical 5. Alright. Do we also have 0? No, we don't. And then is it obvious that 3 minus 2 radical 5 is to the left of 3? So you really don't need to have like, I need a calculator. Yeah, you're an idiot. Okay. Careful. What am I writing here? Negative. You need to be very attentive. We took out a negative sign. Is that clear? Okay, now we can answer the question. increasing and concave down. Is that 3 plus 2 radical 5 comma infinity? Is that clear? Write it down. Oh, yeah, that's about it. As far as explanation, observe your explanation, write down since capital F dash is greater than 0, capital F double dash is less than 0. It says explain.
Your parentheses in there?
I can't hear you.
Parentheses.
Yeah, parentheses throughout, no brackets. Okay, this is only for practice. That is on the BC multiple choice question. Okay, that is a release question. You just have to be slow and steady. It'll kill you only because you're weak in arithmetic, not in calculus. Because it'll be funny, some kid says, actually I'm weak in both. Don't include me in that category, I'm weak in both. Okay, careful. What should I do first step?
Break it up.
Sorry?
You break it up.
Break it up, right? So the top is x to the power of 1 half. Yeah. The bottom is 1/3 minus 1 over, or can I smart it at x to the power of negative 1/3 there? Skip a step. Yes? And then do this yourself, simplify that, do that. Look down. Actually do some work, Mr. Bowie. He's like writing on the table. I'm the Lord, I see everything. What's 1 half minus 1/3? Take LCM, simplify. Or use my fraction trick, just cross multiply and simplify. Those you finish, what do you get? 1/6? 1 half minus 1/3. 3 minus 2 over 6. Alright? So it's x to the power 1/6 minus x to the power negative 1/3 dx. 1 to 64. Now are we ready? So x to the power of times, careful, careful, x to the power of 2/3 times 3 over 2. Lower limit 1, upper limit 64. 6/7. 6th root of 64, 2. It's 2. 2 to the power of 7, 128. Yeah. Okay, times 128. Minus, we're doing the upper limit. Okay, we're doing the upper limit. 3 halves. Cube root of 64, 4. Square it, 16. Minus, what should I not forget?
Parentheses.
Parentheses. Is that stupidly 1? 6/7 minus 3 halves. Okay. Open this up carefully. 128, bloody hell, times 6. Seriously? 720, 48, 768. Okay. Over 7. 48 over 2. I'll leave the 2 alone. Minus 6/7 plus 3 halves. Is that 762 sevenths minus 45 halves? That you can just do the arithmetic carefully. Alright. There are kids who often think, lower level kids, like, what's the use of distributive law? I'm doing math in my head using distributive law very quickly actually. I'm just sharing with you what I'm doing quickly. I did 120 times 6, that's 720, that's 12 times. And then 8 times 6, 48. 720 plus 48, 768. I'm using distributive law. I don't ever know why I'm using it. Alright, copy down 11 please. Again, that's integration practice. Another release question. Another release question. Which bright fellow, nobody speaks for the next 30 seconds. Which bright fellow will tell me how to do this? Oh, that's a typo, there's a dx. What should I do first step? That is an actual release question. Again, it's not complicated. Don't be foolish in thinking integration by parts. Use something. No, it's a very simple. This chapter is not integration methods. It's just simple integration. So what should I do first step? What do you mean? How? She says distributed, but how? Mr. Grover? Thank you. We need to open this up. You need to open this up. Girls writing good notes. Draw a skull, please. First step, expand. They expected you to do that. because you're in the BC class, and then AB, guys, this is AB, this is AB. This is just weird. BC, they expect you to have higher skills. So let's open that up. For those of you who've forgotten, it has 3 terms. It has 3 terms. What's your first term? I'll help you. What's 2x squared times 2x squared? 4x4. Okay, here's what you do next, in case you've forgotten. You multiply these 3 numbers. What's 2 times 3? Times 2? So 12x squared. And then 3 times 3? 9. Now you distribute. So it's 4x to the power of that's x to 1 half, remember? 9 halves. Okay, use the fraction trick in your mind. Plus 12 x to the power of 5 halves. And plus 9 x to the power of 1 half. Can we move on? Okay, it was my job to show you how to set it up. Then use integrate calculator. Don't forget to multiply the reciprocal. Okay, these are interpretation problems. 12, just write down given velocity graph, okay? In your notes, just write down velocity graph. I can give you about 15 seconds. Can you just graph that? Can you just draw that? I'm kidding, Lenore. Lenore will be on it. So like, okay, I got it. Okay, so we won't do any of the questions. We'll set it up though, okay? I'll give you 10 seconds to read and think what's going on, all right? We're given the velocity function. The questions part A says, calculate the total displacement from 0 to 10. So how do I interpret it? What is displacement? We did a problem earlier. How do I find displacement? Anybody? How do you find displacement? Integral of the velocity function. Yeah, the integral of velocity function is a position function, okay, or change in position. That's hence displacement. 0 to 10, v of t. So, do we basically find the area under the curve from 0 to 10? Is that clear? So again, just find the area from 0 to 10. Is that clear? Account for positive and negatives. It's our job, my job to show you how to figure out the problem. Let's do part B. Part B says calculate the total distance traveled by the object. Absolute value. So should I just flip this when I calculate this area? I'm speaking to the board. Should I just flip that? Positive, positive. So distance. Smart kids, please write the left hand side. 0 to 10. Absolute value. Make sure you make all. There is a question like this on your final. I'm letting you know that. Part C. Calculate and interpret A of t. Okay, so today we are also discussing net change, corollary, and so on. Forwards and backwards. It says calculate and interpret 4 to 8 A of t. But keep in mind they're giving me V. So what should I do next step to make it easy for myself? Is that V dash of t? 4 to 8. V dash of t. So what should I do next step? Thank you. Should I use net change theta? Is that V of 8 minus V of 4? It cannot be done quickly. Look about for the fool kids who are not paying attention to the question. Isn't that the area to the curve of the acceleration function? Yeah, but they gave us velocity, you fool. It's not helpful. That's not helpful. If they gave us this, yeah, I can find the area of the curve. That was the previous problem. But this says this. So you have to use the net change. A of t is V dash, and therefore integral of R, this is V of 8 minus V of 4. Can I now just read out the graph? That's V of 8 and what's V of 4? Everybody okay there? You have to slow down. You have to slow down. Okay, D. Interpret the problem exactly the way it's written. D says, calculate the average velocity. So what am I writing? Thank you. 1 over 10 minus 2, 2 to 10, velocity function. Is that just the area in the curve of the velocity function? Let me take it. Just slow down, think through it. There's no rush. Don't memorize any of this stuff. Okay, E. Calculate the average rate of change of velocity from 4 to 16. So how do I interpret the problem? Average rate of change of velocity. V of 4 minus over. Can I just read out the graph? Stupidly simple. I'm just taking different concepts with one graph. Because I'm a badass. With one graph, I can test different concepts. What's the average rate of change of velocity? F. It says calculate and interpret that. Just read left to right. What word am I looking for here? Average. That's how easy it is. So it's the average acceleration. So write it down. Write down the expression because it says interpret. So it's 1/4. That was F. 4 to 8 a of t dt. It is the average acceleration of the object from t equals 4 to 8. Okay, whatever the units are, seconds or whatever. How do we find it? As before. V dash of t. So 1/4 v of 8, v of 4. If you're advanced, how else can I interpret it? The average rate of change of velocity. So make a note, average rate of change of velocity. So the AP would have accepted two interpretations. And I promise you that some kids are just winging it. You had 4 of these questions on your chapter test. You have 2 like this on your final. But there's nothing to memorize, Okay, last one, G. Say, we actually did that, right? Did we do a displacement problem? Okay, I have an idea. Can you hit delete me as reducing? Or backspace. Thank you. All right, now it's a table problem. Similar concept, but the same idea in a table. And this was on your chapter test. I'll give you a table. So in your notes, just write down table of velocity function. Okay, part A. That was pretty stupid. Here's what I'm saying. Here's my stupidity. I say, guys, let's laugh at my folly. I say, calculate and interpret the total distance. What's there to interpret? I say, calculate the total distance. What is there to interpret? Stupidity. All right. It says, calculate the total distance traveled. Okay. Please, I'm begging you, write down the left-hand side. Write down the right-hand side. How do we calculate distance? Absolute value of velocity. Please, like that, inside, from 0 to 10. We've done this. There are kids who forgot to account for it. Okay, it says a trapezoidal sum. What am I really writing? Careful. What am I really writing? It is virtually like this on your final, on your chapter test. What am I really writing? Seriously? Trapezoidal sum?
-6 plus 12.
Wrong. 6 plus 12. Because all velocity is still positive. Okay. 6 plus 12 divided by 2 times 1 plus 12 plus 35.
Is it okay if we just write the beginning and then put absolute value?
No. See, here's my point. You cannot put absolute value here. It's not the absolute value of that. It's the absolute value of every velocity, right? Do you understand that? You can't. We don't care about that guy. We care about individual velocities will turn positive. We're only accounting for either you're moving rightwards. So please write this down. Girls writing good notes, draw a skull because the class seemed completely flabbergasted at that point. This was there on your chapter test. Times 1 plus 35 plus 40 over 2 times 4 plus last. Duck it. Okay, part B. It says calculate what should I not forget in the next step? What should I not forget? Bring down the 110. Now some of you are there for the grading.
Yeah.
I made it a 2-point question. You forgot to write the 110. I take off 1 point. Okay, only half credit. So 110 is that. Oh, should I have actually mentioned Riemann? Which Riemann sum? Is that clear? But otherwise, okay, this is Riemann sum. Next question. Okay, nice. C. Calculate S of 6 minus S of 1. Who can tell me what to write next step? This gives you the velocity. How do we calculate S of 6 minus S of 1? Integral from
1 to 6.
1 to 6 v of t, and then take care of it. Of course, I should have specified the Riemann sum, correct? Everybody okay there? Okay, next change. D as in D arch. Is that actually just stupidly simple? What does that give you? It says interpreted. What does that give you? It gives you the come on, we just went over it. Displacement. Okay. Because negatives would have included, right? Negatives would have been included. Gives you the displacement. Just make a note to yourselves. 2 to 10, because it says interpreted. So it gives you the displacement. Please don't memorize it. So integral velocity is position or displacement, or distance or displacement. You figure out, did we take absolute value? No, we didn't. All right. We're running out of time. I may come back to this, because most of you know how to do this. Okay, we'll do 15. Yeah, we'll do 15. But for the most part, we'll only set it up. 15 says the acceleration of an object is given by a of t. My good man, Lozano, are you keeping up with your homework? He says, man, we have like 6 days left. So today is Thursday. Please understand. Today is Thursday. We have Friday tomorrow, and then 5 days of next week. That's it. So you're taking your final Monday, Tuesday, Wednesday of the following week. Okay. Please keep up with your homework. This is not a time to be slacking off. It says 3 cos t minus 1. Mr. Arroyo, you'll have to bring out the brass knuckles. Okay, and I say v of pi, the velocity at pi is -1. The question says find the velocity at 2 pi over 3. So what is the question asking for? 2 pi over 3 equals v of pi
plus integral pi itself.
pi to 2 pi over 3 v dash of t. But what is v dash really? A of t, so you plug it in. So it's pi, which is -1 plus integral pi to 2 pi over 3. 3 cos t minus 1 dt. That's very easy. Just be slow and steady, careful, arithmetic, keep your arithmetic right. Wait, I'm just showing you how to set it up. All right, question number 16. It says solve the differential equation. They're giving us s of 1 equals 2, write that down. Oh, at this stage, I showed you a different trick to find, we want s of t by the way, okay? So see if this trick comes back. I taught you this like 2 days before the chapter test. Okay, so I need s of t. So what's this? What's this trick? I need s of t, yes, I'm going to solve the differential equation. But I know s of 1. So what's this? So s of 1 plus integral 1 to t is actually s dash of t. And are they not giving us s dash of t? Is that clear? So the trick was that. So 2 plus 1 to t, t cubed plus 1 over t squared. Let's actually do it. Look down. Integral of t cubed plus. Should we rewrite that or we have a formula? What is the integral of 1 over x squared? Negative 1 over x. So negative 1 over t. Lower limit 1, upper limit t. Okay. Slow down, slow down. Okay. 2 plus brackets. Is that just upper limit t 4 over 4 minus 1 over t? Minus 1/4 minus 1. Okay, can we move on? Okay, just open that up. So look at the board please. So if they want a differential equation like that kind of thing, they're all together, just use net change corollary, but make it 1 to x. We will only set up 17. We won't do it, we'll set up 17. It says find the average of that from 0 to pi. Guys, there'll be no surprises. If you understand everything in class and you're doing your homework, there'll be 0 surprises. What am I writing? So write down average equals
1 over.
0 to pi ex minus sine 2x. Okay, we'll actually do it. Look down. Integral of ex. Okay, smart kids, put up big brackets because it's 1 over pi times, correct? Ex. Careful. Louder. Positive 1/2 cos 2x. 0 to pi. 1 over pi, big brackets. First term, look down. First term, e pi plus 1/2. This is 1/2. Because cos 2 pi is cos 360, which is 1. Cos 0, which is 1. Minus parentheses 1. And then plus 1/2 again. Everybody okay there? Will the 1/2 actually cancel? Final answer 1 over pi e pi minus 1. Look down. Yes? Okay, 19. This is again, you're allowed to calculate for 19, not that you need to use one. We just discussed it. Copy down the information in 19. Copy down the information. 19 says if f dash of x, this is a multiple choice question, really easy. Sine of x cubed, you are allowed to calculate it. And f of 3 equals -1. The question says write the equation of the line at x equals 7. So what do I need? Thank you. I need a point and a slope. Show the word. So I need f of 7. Which smart will tell me what to do? Now change corollary. F of 3 plus f dash. And f of 3 is? Can my calculator handle this? This is f dash. Can my calculator handle that? I'll give you the answer in one second. So you have, let's call this monkey. So is that 7 comma monkey? What else do I need to find? Louder? So what do I need to find? What? What do I need to find? F dash of 7. So what do I just do for that? Just plug it in there. Yeah, we know f dash of x. So be alert to what they give you. That is donkey, just plug it in there. Girls writing good notes, you draw an arrow there. And then you write the equation there. Is that clear? Let's discuss B. Same function. Which bright fellow will tell me how to do this guy? Thank you. That's f of 10 minus f of 4. Are we using net change backwards? Is that 4 to 10 f dash? And my calculator handle that. But that was on your chapter test. That question was on your chapter test. Okay? You're allowed to calculate. Yeah, you're allowed to calculate. Of course, I can freak out Mrs. Sanwa. No, you need to do this by hand. I do that. Okay. Oh my God. Am I good or what? Perfectly timed. Last question of the day. You have one question like this. Okay, piecewise function. So, how do I? You don't need to copy the problem. You can directly do it. So, what do I write? -6 to -3. Can you see the break value is -3? Function 2x minus 3 dx plus -3 to positive 3. Look at the upper limit. And then that's -6x squared plus x dx. Okay. What's the integral of 2x? Minus lower limit, upper limit, plus careful, integral of -6x squared. Negative 2x cubed, yes? Because x cubed over 3, -2, -2x cubed, plus biatch, -3 to 3. Okay, now look down. I'm going to walk you through it. First term, second term, 9 again, minus third term, fourth term, plus 18. Okay, plus first term, negative 54. Second term, 9/2 minus parentheses. Guys, I'm giving negative 2x cubed together. Okay, that's like that together. Positive 54? Yes? And again, plus 9/2? Yay! The 9/2's cancel. Yay! You observe that? Guys, do the 54's cancel? No, they add up. Okay. So 9 plus 9, 18. Yay! The 18's cancel. Yay! 18's cancel. So negative 30, it wasn't too bad. So negative 36. Minus 108. Yes. Final answer, negative 144. Okay, since this pen is like Lozano, this will do it. I'm going to try this. Yeah.
You almost got it yesterday.
It's you on purpose. It's you on purpose.
That looked pretty good.
You're
See,
close.
in my AB class, there are kids who cheat and they do it sideways. That's cheating. I want to do it like a paraba.
Proud.
All right.
We're actually,
Thank you. My God, totally right. Guys, Lozano, age and folded hands. Please keep up with your work, man. You can pull off an A on the final. Seriously. Just do the work. Check your solution areas. Contains on the weekend.
they're pretty bad. Ramaswamy, you like my email last night?
We'll be reviewing, tomorrow. We'll start the next chapter reading with integration methods.